Lesson 3. Combustion chambers and airflow. Once air leaves the compressor, it enters the combustion section. You might be surprised to learn that only about 20 to 25% of the compressor discharge air is actually used for combustion. This primary air is mixed directly with fuel to maintain a near-stoichiometric mixture for a stable flame. To keep that flame from blowing out, swirl vanes located around the fuel spray nozzle induce a strong rotational swirl in the incoming primary air, creating a low-velocity recirculating vortex that anchors the flame. So what happens to the remaining 75 to 80% of the air? This secondary or dilution air is crucial for engine survival. Primary flame temperatures easily exceed 2000 degrees Celsius, which is well above the melting point of the nickel-based alloy combustor liners. The secondary air creates a protective cooling film along the liner walls to prevent thermal distortion and stress rupture, and it dilutes the hot gases to a uniform temperature acceptable to the turbine section. There are different ways to arrange these combustors. A can-annular system uses individual cylindrical burner cans arranged inside a common outer air casing. During engine start, igniters in just 2 or 3 cans light the fuel, and flame interconnector tubes transfer the flame to ignite all the adjacent cans. Alternatively, an engine may use a fully annular combustion chamber. This fully annular design makes optimal use of available space, offering the shortest length, lightest weight, lowest surface area, and the most uniform temperature distribution to the turbine diaphanes.